Hello and welcome to our technical talk for Odoo experience. Today we'll be presenting technical challenges for serious gaming with Odoo. My name is Nicolas Rosset. I'm an IT engineer at the University of Applied Science of Neuchâtel, well, HEARC.
And my name is Bernard Letourmy, and I work on software development and operations on the Aroolla project. The Aroolla project is a collaboration between the University of Applied Science in Switzerland, HEARC, and Camp to Camp. The goal of the Aroolla is to create serious game to teach business processes and also Odoo itself. And this in an almost real environment.
So the agenda of our talk, we want to get quickly into the meat of the subject, which is the technical challenges we met. But first, not all of you were there for the previous presentation of Aroolla, so you may need to give a bit of context. So first of all, we're going to talk about Odoo as a serious game. And for those who do not know, a serious game is a game which the main purpose is not pure entertainment. For us, it's a teaching tool. And then after that, we'll talk about the architecture, the infrastructure of our deployment of Odoo, because it may be similar to what you're used to, but we have some slight differences. And then we'll get to the technical issues.
So in the Aroolla games, in the Aroolla family, we have 3 games. We use them in a progressive way. First, there is Mano, which is, in this tool, the players do not use Odoo, but they use a pen and paper and physical objects. This to learn business processes. Then we have Solo, which is a single-player game intended to teach the basics of Odoo. And then we have Largo, which is a contest with multiple players competing in a simulated market. And sorry. And this is we will focus on this last game, Largo, for our presentation. So here, for example, you can see a student playing Largo earlier this year at the University of Lausanne. Here we have 5 players in each row. They are running one of our company in the Largo game.
So all those Largo functions. The players will play normal users of Odoo, really, and our system will do everything else. We have a simulation engine that simulates the markets, the clients, the suppliers, well, everything that is not what the normal users do. They are playing by team. Each team is a fake company in the game. It's a competitive game, as we said. So there is how to say this? We want to motivate them to do as best as they can against each other. Of course, all of this is running under Odoo, and we want to have Odoo as least modified as possible, because our goal is not only to teach business processes, but also the use of Odoo. And all of that is time. It's a real-time game. Each real-time minute is an in-game day. So it must be a bit stressful for students, but that's the goal. So quick recap, it's a competitive market simulation. We have multiple player teams. We want a fast simulation with multiple fake companies, and we want the game to be responsive. There we go.
So to make that game fast, we make one business day into one real-life minute. Which means that every record need to have simulation timestamp. Basically, everything that the user do must have this game time. Then we have we want up to 12 company of 5-user team, allowing for 60 simultaneous players. Then each game, we want each game to start with a clean database, meaning no leftover data from any previous game, only Odoo and our module loaded. This to allow to easily restart a new game after a course for a new course, and without, for sure, the data from the previous course. So that's why each game starts with a clean DB. But the problem is that we want to have real-time and also after the game data analytics to do to let the students do their business intelligence homework. They need to access to the data that were generated during the game and during the course to do their work. So here are the requirements. Now, there is an overview of how we deploy our game with Odoo. So we use Amazon Web Services and Elastic Beanstalk service, which is a service to deploy and scale web application. In our case, we deploy Odoo containers on multiple EC2 instances. The EC2 is the name for virtual machine on AWS. So generally we deploy on 1 to 4 instances for one game, meaning for one class, depending on the load, depending on the number of students mainly. Then with all those instances, we use Amazon Elastic File System to share the Odoo file store. And we then use RDS services for the Postgres Odoo DB, and also for an extra Postgres database that is used for long-lasting data storage. Then last thing is we use also a Redis cluster to allow for fast web session for web session storage on Redis. So then our users just connect to the application, to Odoo through the application load balancer. They also connect, they use Tableau business intelligence application in the cloud also. And Tableau, in turn, will connect back to the data warehouse to fetch the data that has been produced by the game in real time.
All right, so before we get into the challenges, this is our view of Odoo. That's what the players see. So for those who actually have used Odoo here, you will see almost no differences except a little orange banner on top. That's our thing. It just shows the players information about the game itself, which is which day is it, because they have time. It's a timed game, so they need to know where they are at. And also the fake timestamp that we're giving them, which fake day is it today. And also for the admins, the lecturers, the teachers who are actually running the simulation game, they have their own view that doesn't appear on this screen for some reason. But we have it on ours. Is it an animation? No, it's not. Yeah, there it is. So we have this screen, and it shows that you can configure the simulation to make it harder or easier for the students. For example, they can automate the purchasing orders. But it's also important for the administrators because you can monitor how the simulation is doing. You're going to see that it's a quite performance-heavy simulation, so we need to know if things are going well or not.
Yeah, here we can see that we have a lot of things going on in the background during our one game day, 1 minute in fact, 1 minute day. So we have many business functions that run on multiple workers in parallel. And those workers are kind of like Odoo cron standard worker, except that we have a lot of them, actually 12 cron workers by host, and they run continuously instead of being executed periodically and having only a few of them on a typical Odoo setup.
And when we are talking about all those jobs, this is once again a bug. Let me just get it right. So those are charts of the resource usage of our system. On the left is the CPU usage. You don't see it, but it goes almost up to 2 CPUs. And on the right is the memory usage. It goes almost 1 gigabyte. This is without any user. No one is playing right now. But we're still using a lot of resources. And that's just the simulation engine, doing automating thousands of transactions and lots of things. And all of those things, all of those transactions and the system, is going to bring us a lot of technical issues.
So anybody who has already used multi-host Odoo for any other purpose face that kind of issue. You have to share the file store. Otherwise, if you have multiple hosts connected to the same Odoo database, then you will have issue of losing attachment in documents, or also possible broken Odoo interface because the front-end compiled web assets are also stored as attachments in the file store. So you really want to keep them in sync. But OK, this one is quite easy. We share the file store using Elastic File System in our case, but it's just through standard NFS.
While we're still on the subject of multiple hosts for Odoo, if any of you has already tried to deploy Odoo themselves by using Docker, for example, you will see that you can use an option that we use, which is to initialize the module instantly. No need to install them manually with the interface. When you do that, it works very well. But if you have multiple Odoo trying to do the same thing at once, you will see that they're all trying to initialize the database at the same time. That's something that you don't see in a normal deployment, because usually you would just start with one host, and then when your company is growing, or if you have more users, you just deploy more hosts, really. So you have no problem with that. But we want to have multiple hosts at the same time. We want to have hands-off deployment. So the problem is that, well, there is a simple solution. You will tell me you can just have one Odoo that does the initialization, and the other will just not do the initialization. If you do that, they will still try to connect to a database that is not ready. So you have two scenarios. Either you have a broken, never-ending loop of failed initialization, or you have random load balancing where 1 on 4 requests is going to work, which doesn't sound too tempting to me. Our solution is a bit weird, but we wrote wrappers, 2 kinds of wrappers that is around Odoo. We have initialization wrapper. This one is working alone. It will just start Odoo to handle the initialization of the database, and at the same time act as a web server that answers if the database is ready or not. The other kind of wrappers will be every other Odoo hosts we use, and they will just wait for the database to be ready, and when the database is ready, they just start up Odoo, and everything works well. This allows us to start any kind of deployment we want with 8, 16, or 20 hosts at the same time, without having to wait which one is doing the initialization, which one is ready, which one is not. Usually we have those problems that are very specific to our case, but this one may actually be useful in a normal case if you're using Kubernetes, for example, which is a very common orchestration nowadays.
So now we have our hands-off deployment, and we can, our database is ready, so we can start the game, and then it becomes slow, we have bugs, So we have too many SQL transactions running at the same time by both the worker, the simulation worker, and the many users that are connected at the same time. So we lost. No. Sorry, we don't. So to solve this problem, what we did is to organize the sequence of job, the one that we were seeing on the graph before. Organize the sequence of job to avoid any as far as possible to avoid to run in parallel the one that access exactly the same data, and then if for the remaining of data we detect the deadlock the deadlock exception in our robot, and we simply retry the transaction the next time, exactly like Odoo does when it's a user connecting and encountering some issue with too many access to or a second access to the same data. Okay. Then we said we wanted to clean the data after each game, but still access the data. So to do this, we need an extra database. We use a data warehouse, a second Postgres database, as you've seen in the architecture, to store the data and to save the data of the game in real time during the game. So to avoid the issue, because this is again an extra load, an extra work needed on the database. So to minimize the issue, we implement this transfer mechanism as a job that is executed at the end of all jobs of the day, and so that also we have consistency of the data. We want all the business transaction of that day to be terminated, so that we transfer a clean state of data, and we only transfer the delta from the previous day, and we do this by using triggers and PostgreSQL stored procedure directly on both the Odoo DB and the data warehouse DB, to avoid having to do too much work with Python and the ORM. We let all the transfer job to be done by the database themselves.
Okay, so we told you that between each game we want to clean the database. That's a specific use case also to teaching, because I wish you all well, and I wish you do not have a post-game of your company. So I hope you also keep your data nice and well, but we don't. We want to remove all of that. But we also don't want to lose the Odoo initialization and the modules loaded, because it just takes a long time to install every time. So every time we change a class, we don't want to wait a few minutes for that. We want to wait a few seconds. Our solution is to use actually a mechanism of PostgreSQL. We just, every time we finish the first initialization of the database, we just do a PostgreSQL snapshot. And when we want to restart a game, by just cleaning the previous game data, we simply kill the connections of the active users, and then we drop the database and restore our snapshot. It just makes us gain a lot of time. And the last technical issues, but not the least at all, if I may, is the fake time management. Once again, very specific use for us, because as we said, we want 1 minute to be in-game day. However, for a normal use case, I would advise you not to play with time, because it's going to make your accountants very angry, I imagine. We want to modify every single record, every single thing that Odoo makes to be on a fake time. We have a technical solution for this, which is to use patching. But patching comes into multiple forms, and we're going to use 2 of them. We use monkey patching. Monkey patching, a funny name perhaps, but in programmation, it means changing code at runtime. So when the code is actually running, we just swap around a few functions just to change, to make Odoo believe it's actually still using the right functions, but it's not. So we're going to make him believe that he's asking for time, but he's actually asking for our fake wrong time. However, Odoo is well made, and it's a multi-process program. So even if we do that, we still have some HTTP workers in the background which are still going to ask for the actual real time. And that's the part where the thing we try to avoid the most, we have to do it. We have to actually patch Odoo's code. A small thing just is to do a regular patch to change how the HTTP worker actually synchronize between each other. So we're going to make each HTTP worker synchronize their time together. That way, every time a transaction is processed by our simulation engine, we are sure they are all using the same fake time and not discrepancy of 1 today or even the real time for some of them.
So we have seen that we have some very specific problem, like the fake time management, with some specific solution, and then some more general problems that are shared with any high-load deployment of Odoo. And Odoo, being open source, allowed us to handle these non-orthodox use cases and to implement the solution created by these use cases. And okay, we hope that maybe it could also help for some of your very specific problems.
Thank you. Thank you for coming.
Thank you.
Nicolas and Bernard, thank you so much. Does anyone here have any questions that they would like to ask? Anyone? Well, if there's nobody, let's thank them again for
Thank you very much.
Thank you very much.
pushing Odoo beyond its limits.